Hello, everyone. In this video, we will demonstrate how to identify metal cations using the flame test. Presented by the Department of Chemistry, Faculty of Natural Sciences. I want to ask you this before we begin the demonstration. Have you ever wondered why the regular fire is orange-yellow while the fireworks have so many different colors? Let's investigate that question in the laboratory. Yes, you heard that right. We will investigate the chemistry behind fireworks. To uncover the mysteries of the fireworks, we will employ a technique known as the flame test. The flame test is a technique that involves heating metal cations in a flame and observing the color they produce to identify a particular metal cation. The flame test enables qualitative identification because different metal cations produce distinct flame colors. I'll now guide you through the steps to perform the flame test safely in your laboratory. Before conducting the flame test, wear personal protective equipment, including safety glasses, a lab coat, gloves, and closed-toe shoes. Make sure your long hair is tied back. Avoid wearing dangling jewelry. To perform the flame test, we require a lighter or a box of matches, a platinum or nickel chromium wire loop, a Bunsen burner, concentrated hydrochloric acid, a bottle of distilled water, a beaker, watch glasses, a cobalt glass, and finally, the samples. 5 different solid samples, 1 semi-solid sample, and 1 solution sample will be used in this demonstration. You can see that 4 solid samples are white, and 1 solid sample is green. The liquid sample is also blue. Salt is either dissolved in water or the solid salt itself is used for the experiments. The salt solution needs to be highly concentrated to produce an intense color in the flame. Therefore, a solid sample is preferred as we can perform the test with a tiny amount of sample. Before we begin, let me ask you a question. Can the color and nature of the samples be used to identify them? Despite its limitations, identifying samples purely by their color and nature can provide initial data for further investigation. Color can serve as a preliminary indicator. One of the samples is green in color, and the solution has a light blue color, however, it is insufficient for a conclusive identification. I remind you, why do we carry out a flame test for metal cations? The answer is to identify the metal cations by their distinctive flame color. Now we are going to start the flame test experiment. The first step is that you need to light up the Bunsen burner. First, connect the hose that is connected to the Bunsen burner to the gas line from the other end. Then, check whether it is firmly attached. Only after that, line up the gas tap with the hose to open the gas line. Take the lighter onto your hand, and keep it close to the barrel chimney. Then open the gas valve. Then immediately light up the burner. Do not wait too long. You will observe a yellow-orange color of the flame. This flame is also called the safety flame. After that, you are going to adjust the flame to blue. To make a blue flame, you will turn the barrel on by opening the air hole. Do this by holding it at the base. If you get the blue flame at the first point, you should not worry about that step. Now, you change the color of the flame from yellow-orange to blue. You will also want to make sure not to let too much air in because this can blow out your flame. You will know that your flame is ready to use when it is dark blue with a darker inner core. The blue flame on a Bunsen burner generates the hottest flame. You completed the first step of lighting the Bunsen burner. Never leave the open flame unattended. The second step is to take the required concentrated hydrochloric acid. We will obtain a small sufficient volume of hydrochloric acid into 2 separate watch glasses. One solution is to clean the loop, and the other is to test the samples. After taking the reagent bottle from the shelf, first we loosen the cap. Then we take the bottle cap off using our middle finger and the ring finger, and keep the cap neck upright between fingers. Then gently pour a sufficient volume into a watch glass. After taking the hydrochloric acid, close the cap tightly and return the reagent bottle to the shelf. The third step is to perform the flame test using a platinum wire loop. Now I will demonstrate how to perform the flame test using one of our samples. First, clean the loop with distilled water. Then, clean the loop by dipping it in hydrochloric acid. Finally, place the loop in a blue inner core flame to see how clean it is. Remember that if the recommended colors are not produced, the loop has not been sufficiently cleaned. You may need to repeat the process multiple times. The loop must be cleaned before the test. After cleaning the loop, always place it on a watch glass if needed. And take the sample you are going to test. Again, dip the clean loop in the concentrated acid assigned for testing the samples. Next, dip the clean loop in either powder or salt solution. Place the loop with the sample in the blue inner core of the flame. After that, take a note on the observed color. The same loop will be used for the testing of each sample. Therefore, repeat the process of cleaning the loop many times as needed. Before testing the second sample, clean it with distilled water, then dip it in hydrochloric acid, and finally ensure the cleanliness by inserting the loop in the flame. If you observe a yellow color with your test sample, you also need to observe the color with a cobalt glass. A cobalt chloride glass is used to observe the color of cations such as sodium and potassium ions, as it absorbs the yellow color of the sodium and the lilac color of the potassium will be visible. The reason is that most sodium salts are contaminated with potassium, or vice versa. So, sodium can interfere with the determination of the color of potassium. You have now completed testing the samples. The fourth step is before you store your loop in the proper place, clean it by repeating the cleaning steps. The fifth step is to turn the Bunsen burner off. For you to safely turn off a Bunsen burner, first return it to the safety flame, or yellow flame, by closing the air intake from the barrel. Next, turn off the gas valve on the Bunsen burner itself. Turn the gas tap off. Finally, disconnect the hose from the gas tap. You have completed your experiment. The final step is the cleaning of your workstation. Discard the used reagents as instructed by the demonstrator. Clean the glassware and lab bench. Return the items to the designated places. By performing the flame test, you learned what you would observe in the flame test. Rainbow colors can be generated from metal cations using a blue flame. We have 7 different samples. Consider how you identify a metal cation by its distinctive flame color. For that purpose, we often refer to the table that is conducted on pure metal ions. Let's identify our samples. From the table, red color is produced from lithium ion in the sample 1. Orange is from calcium ion in the sample 2. Yellow is from sodium ion from the sample 3. Green is due to barium ion in the sample 4. Blue-green color is due to copper, 2, ion in the samples 5 and 7. Potassium ion in the sample can produce lilac color, which you should observe through a cobalt glass in the sample 6. Solid sample 5 is green and solution sample 7 is blue, however, both produce blue-green flame color, indicating the presence of copper in both samples. This implies that color does not provide conclusive observation. Why do we see different colors with different metal cations in the flame test? First, by mixing with concentrated hydrochloric acid, the metal cation is converted to its chloride form. Consider the sodium chloride salt of the metal in solid form or solution. When a sodium chloride sample is in solution, the chloride and sodium ions are surrounded by water molecules. In both solid and solution, water causes the hydration of the ions in the salt. Then the compound moves to the hottest part of the flame, where water evaporates and the molecules dissociate into gaseous atoms. The salt sodium chloride, sodium ions can gain an electron from an anion and become an atom. Let's look at the ground state electron configuration of the sodium atom. That is 1s2, 2s2, 2p6, 3s1. Here, the heat excites the outer shell electrons of the sodium metal atom to a higher energy state. For sodium, 3s1 electron is excited to the 3p higher energy state. The energy requirement for this excitation exactly matches the energy difference between 3s and 3p. Once excited electrons are unstable. Therefore, an electron spontaneously emits energy in the form of photons in the electromagnetic spectrum and returns to a lower energy state. For sodium, it will emit energy that is the energy gap between 3s and 3p in the form of a wavelength. This energy gap matches the energy of yellow radiation of the visible region of the electromagnetic spectrum. Therefore, upon returning to the ground state, sodium emits yellow color radiation in the visible region, having a wavelength range from 565 to 590 nanometers. You can illustrate this transition using an energy level diagram. Let's introduce, what is the electromagnetic spectrum? The electromagnetic spectrum is the name given to the collection of all electromagnetic radiation in the universe. This is in the form of electric and magnetic waves, allowing for the transfer of energy. In the electromagnetic spectrum, there is a region called the visible region that consists of 7 colors of the rainbow. If the photon emitted by the metal cation is one of the 7 colors in the visible region of the electromagnetic spectrum, you can see a color. This emission is specific to a metal cation. That is why you see the characteristic color in the flame. A flame test is the simplest way of identifying the presence of metal ions in the compound. Concluding remarks. Can we confirm the identification of the metal cation by only performing the flame test? The flame test has some limitations. 1. Not all metal ions emit color when heated in the flame. Second, the test cannot detect low concentrations of most ions. Third, the brightness of the signal varies from one sample to another. Fourth, impurities or contaminants affect the test results. Fifth, the test cannot differentiate between all elements. Therefore, the flame test can only give you a hint of what cations are present. However, for a purified or pure sample, the flame test is considered a confirmatory test. Question time. To test your understanding, attempt the following questions on the flame test. There will be 8 multiple-choice questions, with 1 minute per question. Find the most suitable response. After 1 minute, the correct answer will appear in green. Question 1. In this video, we have mentioned a few advantages of the flame test. One of the advantages would be: answers are: A. Requires a long time to perform the test. B. Difficult to perform the test. C. Requires a large amount of sample. D. A flame test is effective for narrowing down the possible cations in a sample for further analysis by identifying which metal ions are present based on their characteristic flame colors when heated. The correct answer is D. Question 2. When a metal atom is heated in a flame, what subatomic particle is excited and moves to a higher energy level? Answers are: A. Proton. B. Neutron. C. Electron. D. Nucleus. The correct answer is C. Question 3. Light is emitted in a flame test when electrons move from the. Answers are: A. Ground state to the excited state. B. Excited state to the ground state. C. Excited state to another excited state. D. Ground state to another ground state. The correct answer is B. Question 4. Which of the following metal cations cannot typically be identified by a flame test because its electrons are too tightly bound? Answers are: A. Sodium. B. Potassium. C. Magnesium. D. Lithium. The correct answer is C. Question 5. What is the primary purpose of using a Bunsen burner in a flame test? Answers are: A. To provide a fuel source. B. To create a high-temperature environment for exciting electrons. C. To remove impurities from the sample. D. To produce a colored flame for comparison. The correct answer is B. Question 6. Why are chloride salts sometimes used in flame tests? Answers are: A. Chlorides enhance the color of the metal ions. B. Chlorides have very low melting points. C. Chlorides help the metal ion vaporize in the flame. D. Chlorides are good electrical conductors. The correct answer is C. Question 7. What is the most common explanation for why different metals produce different colors in a flame test? Answers are: A. They have different crystal structures. B. They have unique electron configurations, leading to different emitted photon energies. C. They have unique atomic masses. D. They have different types of chemical bonds. The correct answer is B. Question 8. The flame test is primarily used to identify the presence of what type of substance? Answers are: A. Metal anions. B. Metal cations. C. Organic compounds. D. Nonmetals. The correct answer is B. I think you have learned about the flame test. Thank you so much for listening to this video.